Here we have our next problem, and it's asked us to evaluate the cosine of 120 degrees. So that is a trigonometric problem, or trigonometry problem, or people just say a trig problem. Okay, let's do the cosine of 120 degrees. First of all, let's draw the angle on the unit circle. So here we have our unit circle, and the unit circle starts from here, and right over here we have 90 degrees, but 120 degrees is larger than 90 degrees, so we have a little more over here. That is 120 degrees, and that would be our angle over here, that 120 degrees angle. Or I guess I should probably do it in another color. You know what? Let's just do it in another color, so it's more clear. So this is 120 degrees, and our angle, this would be our 120 degree angle. Cool. And we know that on the unit circle, the x values the cosine values are the x coordinates, and the sine values are the y coordinates. Over here, we know the horizontal axis is the x-axis, and the vertical axis is the y-axis. And we know that x is positive over here on the positive side, or on the red side of the y-axis, and x is negative on this side. And since the angle, or the point over here, is on this side of the axis, and the cosine is the same as the x values on the unit circle, we know that cosine is negative. So just a note here, note that cos of 120, it's negative. We also know that the angle that we need to use is 30 degrees, because right over here, this angle is on the second quadrant. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. I know it goes this way instead of like the normal way that we usually do it, but that's just how math works. So this is the second quadrant, and you know for the second quadrant, our reference angle is 180 degrees minus theta, and the theta we want to know is over here. We know that the theta we want to know is 120, so we have 180 degrees minus 120 degrees equals to 60 degrees. And we know that 60 degrees is our reference angle. Also, the blue line should probably be more over here instead of over here, but it's okay. Okay, so reference angle is 60. Now, we just need to use the special triangle to find the exact value. We have two special triangles. The one we need to use here is the one that has the angle 60, which is this angle, or the triangle we need to use here is the triangle that has the value 60, which is this triangle over here. And the angle here is the 60 degrees angle. The angle there is the 30 degrees angle. I'll just label it for your sake, but we don't need this angle for this problem. Again, we are trying to get the cosine, or the cos of 60, this cos of 60, and the cosine is equals to adjacent over hypotenuse. So the adjacent of the 60 angle over here is 1, and the hypotenuse of the 60 triangle here is 2. So we have 1 over 2, and that is the cosine of 60. However, the question didn't ask for the cosine of 60. The question asked for the cosine of 120. And we know that based on our result over here, that the cos of 120 is negative based on our unit circle. So we know that the cosine of, or the cos of 160, the cosine of 160, or sorry, the cos of 120, or the cosine of 120 is negative. So the cosine of 120 is negative 1 over 2. Negative 1 over 2. And that completes our solution of finding the cosine of 120. Now let's check out the sample solution given. The sample solution given. The sample solution here, again, they also try to find the reference angle. They also write at the answer that the reference angle is 60 degrees. And yes, again, the cosine function is negative in the second quadrant, so we have the negative 1 of 1/2. It's the cosine of 120. It might be a little confusing here that they did cosine of 60 equals 1/2 equals negative 1/2, but they just meant that the cosine of 120 is negative 1/2. Or at least I suppose that's what they meant. Okay, so let's say the solution is correct, although it can be formatted better, but it's correct. Let's just say the solution is correct. Okay, let's move on to our next problem.